Now let's modify this problem a little bit. We have some new rules, and it is called online version rules. So first of all, after each interview, we must either offer the position to the applicant or reject the applicant. But different from the previous version, which you can hire different candidates, here you can only hire once. Okay, and of course you want to hire the most qualified person as your assistant. But how? Right? Here is a simple strategy. Choose a positive integer k smaller than n. Here n is the number of applicants you're going to interview. So k must be smaller than n. And then interviewing and rejecting the first k applicants. So basically you don't want to hire too soon because you want to see what is the quality of your applicants for a moment. And then hire the first applicant who has a higher score than the first k applicants. Okay, which means after you have seen k applicants, you know what is the highest score, and then you hire the first applicant who has a higher score than the first k applicants. Okay. You may have this question, okay, what happens if the best applicant is indeed within the first k applicants? If that's the case, you'll hire the last one. Okay, which is very unfortunate, but sometimes it happens. So this is also called the optimal stopping problem. Okay, there are some real-world applications like this. For example, if you want to rent an apartment, you may want to first just looking around for a moment, and then rent the apartment that is better than the one that you have seen so far. However, you don't want to look around for too long, otherwise you may miss some really good apartments. So you want to know, for this simple strategy, how to choose k such that the probability of hiring the best candidate is maximized. It turns out for this simple strategy, if you choose k equals n divided by e, here e is the Euler number, which is the base of the natural logarithm, the probability of hiring the best one is at least 1 over e. Okay, so 1 over e approximately equals 0.37, okay, so which is not that bad. So according to this simple strategy, for example, if e equals 10, then you probably choose k around 4, and then the probability of hiring the best one is at least 0.37. Okay, so it's not that bad. So this is the discussion of this online version of hiring assistant problem. If you're interested, you can check the textbook, and there is a discussion on this conclusion.